Hi everyone. Today we'll be building 4 machine learning projects in Python. So let's get started with our first project, which is predicting Apple stock with machine learning. The first thing we'll do is we'll import a package called yfinance. Import yfinance as yf. This package calls the Yahoo Finance API to download daily stock prices. And the first thing we'll do is we'll initialize something called a ticker class, which will enable us to download price history for a single symbol. In this case, we'll be using Apple ticker class. Oops. So we'll go ahead and run this. And the next thing we'll do is query the historical price. So we'll use a history method here. Let's use the history method. History period is equal to max. Let's run this. And we'll pass in period equals max, which will query all data from the very beginning. And so let's create just Apple. As we have run this last cell, we end up with Pandas data frame, which is very nice, as you can see. And this data frame, each row is the price of Apple stock on a single trading day. So as we can see, I think non-trading days are not included in this data. The column are like opening price. There's a price when the market just opened, and the high price, like the highest price during the day and the lowest price during the day, and close, which is like the price of the stock when stock exchange has closed. And we have volume as well. And so the total volume in that particular trade day. So we are essentially going to use these columns to predict if the stock price will go up or down tomorrow. But we have like some additional columns like dividends and stock splits, but we are not going to use this last two columns, and we'll actually remove them later. All right, so we'll take a look at the index of Apple. Let's have a look. Apple.index. As you can see, we have a date time index, and the index is a column on the left. Okay, great. Next thing we'll be doing is we'll plot the data in the data frame. So we'll plot the closing price against the index. So what it's doing is it's showing the index, which is really the trading days, the dates on the x-axis, and shows the closing price on the y-axis. And so we can run that, and we get a nice chart of Apple stock price history, and we really can regret not buying this Apple stock at any time in history. Then let's do a slight bit of data cleaning. Let's do it here, control. We can run this code, and we can remove these two columns that we had just said earlier. So the next step that we are going to do is like we'll be setting up our target. Like, so the purpose of our machine learning model is predicting the stock, but like we had set up our target for that. So let's to do that, let's actually create a new column called tomorrow, and let's use a shift method for that, and let's actually create it like this. As you can see, the closest each day has been shifted to the tomorrow of the yesterday. Let's have a look at 16th of December 1980, If you look at the close value like this, is equal to the tomorrow value of yesterday, which is 15th of December 1980s. Then the next thing that we are going to do is will be setting up a target, and like it should return a boolean, so that like if the tomorrow's value is greater than the close, uh, it will return one. But like we want to turn that into the integer with the as type. This. So let's say it here like this. Um, Now we can see like uh, close value is greater than the tomorrow's value. So this 0 because close value is greater than. And if you look at here, close value is actually lower than the uh, tomorrow's value. So it's returning the target 1. So let's come here and let's create the next thing we actually want to do is we want to see mostly last 20 plus years, so we want to get rid of all the years before 1990 is 1st of January. So let's see it here like this. As you can see, we have removed the previous dates data, and as you can see, like there's a target column and tomorrow column here. All right, let's start the most exciting part. We'll be building our first machine learning model. We'll be using random forest classifier for this. For some reasons, random forest classifier does not overfit most of the time compared to other models. One more advantage of this model is it runs relatively quickly, so I think it's a better model to use for this project. So let's initialize our project like this. Here we pass some parameters, an estimators, which is like number of decision trees we want to train. Usually higher this is, it's better for accuracy. Let's put it 100 for now. And minimum sample split, mean sample split. This helps us to protect against overfit. And let's set random state is equal to 1. Now let's split our data into train and test dataset. Well, actually this is time series data, so we cannot use cross-validation as it may show us results that actually might be really good when we are training, but not that good in the real world. Because in the cross-validation, we might be using future price to predict the price in the past. For those reasons, let's put all data except the last 100 rows to our training data and the last 100 to our test dataset. Now let's create a list called predictors to predict with all the columns to predict the targets. We'll be using close, volume, open, high, and low columns for this part. And common mistakes we could have here is that we might use tomorrow or target column in our predictors to predict target column, which is obviously not right. Now what we are going to do is to fit the model. As you can see, we are using here list predictors to predict the target. Let's run this. Okay, it doesn't end up here. We'll be measuring how accurate the model is. So let's start by importing precision score from Scikit-learn metrics. And let's also generate predictions using our model. Here we use predict method and pass test dataset with predictors that we have created earlier. So now if we run this, and if we run prats in a new cell, We can see that it's a NumPy array, which will be a little bit hard to work with. So let's make this a Pandas series. To do that, let's start by importing Pandas. Let's run this. And if we rerun the preds in new cell, we can see that Pandas series here. The dates with target, which is, I think, easier to read than the previous one. Now we calculate the precision score. To do that, let's write precision score test target, and let's pass in threads. Let's put it. Well, I think our precision score is really good than I expected, and like it's basically saying that our model, like if our model has predicted that stock price will go up, 78% of the time it's right. It actually go up. Now let's actually plot these predictions with pandas concat function. Here we actually plot the actual values of a stock and predict values of a stock, Apple stock in our case. And the orange line, like with a zero, is our predictions, and blue line is actual value of a stock. So we have built our model, but to make it more usable in the real world, we have to backtest it with historical data and see how it performs. Let's start by creating a prediction function that it will wrap up everything with it to just one function. So let me explain what's going on there. Here, so we create a predict function and we just did what we did earlier, like fitting the model in this line and like generating the predictions, then turning them into Pandas series and concatenating it. Let's run this. Now let's create a backtest function. Let me explain what's going on here. We passed our data, model, and predictors. And what's the start value here? Well, for training, we want to have certain amount of data to backtest our model. One year usually has around 250 trading days, so it will be taking around 10 years of data for training. Step is like 250 here, which means we'll train a year, then go to the next year, and then go to the next year, and so on. It basically means that we'll first take 10 years of data for training and predict 11th year, and we'll take 11 years of data and predict 12th year data, and so on. In this backtest model, we create a list called all predictions, which will be a list of data frames where each data frame is a prediction for a single year. Then we create the function to loop through the data. After that, we create the training set and test set, where training set will be all the years prior to the year we want to predict. And we set up predictions and we append them. Then let's do backtest with Apple stock, our model, and predictors. Let's do it predictions. Let's run this. Oops. We forgot trying this. Let's run this. Now let's come here. Let's run this. After having initiate backtest, let's start analyzing error rate for our model. To do that, let's have a look at precision score. Here it is. Let's run this. Oh, it's 52%, which basically means that like if our model has predicted that stock Apple stock price will go up, 52% of the time is right, or if it says it will go down on a particular day, so it's like 52% of the time is right. But like as you can see from our like previous precision score, when we have just test our model, it was like 72 or 78% or something. So we can see that if we backtest, it's not performing as you have seen earlier. If you are here until this part of the tutorial and it was helpful, I'm really happy for that. But before moving on to the last part, I want to see how helpful was this video. Could you comment in the comment section below if you want me to create last part of this video, which is adding additional predictors to further improve our model. Also, it would be so helpful if you subscribe and like. As always, thank you very much. Hi everyone! Today we'll be implementing k-means clustering model from Scikit-learn library to build customer segmentation project. Customer segmentation is usually used by marketing teams to divide customer base into distinct group of individuals that have similar characteristics. That process makes it easier to target specific groups of customers with tailored products and services. For a dataset, I looked up to the Kaggle, and if you come here to the dataset section in the left sidebar, you can search here the dataset that we want. In our case, it's customer segmentation. Let's search for it. And we can see here that more than 100 results, and I usually go with the first one. It usually works for me, but let's have a look inside. And here, if you look at the data, we have customer ID column, gender column, age, annual income, and spending score. Well, let's actually use this as our data set. We can download it from here in the download button. And if we jump back to our Google Colab, we can upload it from here, from the upload button. And after uploading, we can start our first step. All right, let's get started. We'll be going through 3 steps in this project, and first one is importing required libraries and exploring data. We'll be using Pandas for this project to work with our tabular data. It makes it easier to manipulate data frames. And we'll also be using Matplotlib, which is a library for making graphs and showing images. It's useful for displaying our results. After importing libraries, we can read our CSV data with read CSV function from Pandas. But make sure you have uploaded this or your own dataset before running this cell. And also here we are setting it to the variable df. And we can also have a look at first few rows of our dataset with head function here, as you can see. And 10 here means it will show us first 10 rows of data. So let's run this cell and have a look if we have read our data properly. Nice. As you can see from here, we have customer ID column, gender, age, annual income, and spending score, as in our original dataset. For simplicity of this project, we'll be using only salary and spending score. More on that later on. Next thing we are going to do is let's see how many rows and columns do we have in our dataset. We can do that by using shape function from Pandas again. So let's run this, and here we can see that 200 rows and 5 columns in our dataset. And also if we run df.info on our new cell, we can see here all of our data is non-null, which is basically means we have really clean data set. Also here we can see our data types are numerical for all columns except gender. This one is, of course, this one is categorical. Anyways, we won't be using that column today. All right, we are now ready to go into the second step, which is preparing our data and finding optimal number of clusters with the elbow method. Well, a little about elbow method. Elbow method is a graphical method for finding the optimal k-value in a k-means clustering algorithm. And first we'll be extracting values from third and fourth column, which is annual income and spending score, and storing them in a new variable called new data. We can also visualize new data. Let's visualize it with entering new data. And cool, here we can see only third and fourth columns. By the way, if you are wondering why annual income is very low here in this column, it's in the thousands of US dollars. So here in last row, for example, it means 137,000 US dollars. And now let's import k-means class from Scikit-learn.cluster module. Scikit-learn is a scikit-learn library, a widely used machine learning library in Python. And also let's initialize an empty list named WCSS. By the way, this is not from CSS in the front-end development. It basically stands for within cluster sum of squares, which is the sum of square distance between each point and the centroid in a cluster. When we plot a WCSS with a k-value and plot like an elbow, and the number of as the number of clusters increase, the WCSS value will start to decrease. And the idea is to choose a number of clusters k that minimize the WCSS. And our list here will be used to store the WCSS values for different number of clusters. Now let's run this. Next thing we are going to do is let's create a loop to fit the k-means clustering algorithm with different number of clusters and and calculate the corresponding within cluster sum of squares WCSS for each configuration. And here inside the loop, a k-means object is created with the current number of clusters I, and clusters is equal to I, and the init equals k-means plus plus. Parameters specify that the algorithm should use a k-means plus plus initialization method, which is a smarter way of initializing cluster centroids. And also here we are setting a random state to 0. And here this line fits the k-means model to the data, our new data, which is it assigns each data point to one of the clusters. And after fitting the model, the WCSS for the current number of clusters is calculated using the inertia attribute of the k-means object. The WCSS value is then appended to the WCSS list that we have created earlier, capturing the variability with the clusters for different number of clusters. After running this loop, the WCSS list will contain WCSS values for cluster numbers ranging from 1 to 10. This information can be used to visualize the elbow in a plot and help determine the optimal number of clusters for a given dataset. The optimal number of clusters is often where the WCSS starts to decrease at a slower rate. We are having some errors warnings here, but let's not worry, at least for now, and see how it goes. Now let's create a plot to help identify the optimal number of clusters with Matplotlib library. Let's set up a title elbow method, and on the x-axis we'll be having a number of clusters, and on the y label we'll be having WCSS values. And here in the last line we have plt.show, which basically visualizes our plot. Cool, we have a plot here, and we can see that line decreased drastically from when number of clusters is 1 to number of clusters is 3, is somewhere 3. And we can see here it starts to slow down until 5, and from 6 it really flattens. So in this case 5 would be ideal elbow, so we can assign optimal number of clusters as 5. Let's move on to the last step, which is training our model. To do that, first let's start by by initializing k-means model to cluster the data into 5 clusters, as we just did before, but only for 5 here. And now let's also fit our data, our model to new data. After running this code, k-means will contain the cluster labels assigned by the k-means algorithm to each data point in new data. Each element in k-means represents the cluster assignment for the corresponding data point. Now let's create a scatter plot to visualize the clusters formed by k-means model. This line here creates a scatter plot for cluster 0 and new data y k-means 0, 0. This part means the x coordinate values for data points in cluster 0. And this one is respectively for y coordinates. And here we have like s is equal to 80. That means marker size is set to 80 and marker color is red. And here in the last part we have a label. It's assigned to for the legend indicating the cluster number. And also now let's do the same for clusters 1, 2, 3, and 4, as we just did for cluster 0. And here this line adds scatter plots for the centroids of each cluster. We'll be having 2 centroids, x and y, and these points are marked with black color and larger size. That means that's why it's 100 here. And here it adds a title, and we have x-axis and y-axis, y label, and we have a legend here. It basically adds a legend to the plot, displaying the label specified in the scatter plot commands. And this one basically displays the plot. And let's run this and see how it goes. Voila! We have a nice plot of clusters as we just wanted. Let's analyze this colorful plot a little bit. You can see that customer group 4 with yellow label has lower salary here, as you can see on the x-axis, but higher spending score. And on the other hand, we can also see that customer group 1 with a red label has a higher salary but lower spending score. So if you are, for example, in a marketing department, you may want to target clusters blue and green, which has higher salaries and higher spending scores. Hi everyone, today we'll be predicting the weather using Pandas library and regression model from Scikit-learn library. For dataset, I looked up to the Kaggle, and if you come here to the dataset section in the left sidebar, let's search for weather, and we can see these results. Quite a lot of number of datasets that are out of. And even though this first one is not updated since 2 years ago, usability seems to be 10, and there are quite a lot of number of upvotes. So let's have a look inside how it goes. There seems to be precipitation columns, maximum temperature column probably during the day, and minimum temperature during the day. So this seems to be a Seattle weather. So let's actually have a look at here. Let's use this as our dataset. We can download it from here, from the download button. And after downloading the dataset, let's jump back to our Google Colab. And here in this button, in the left side, we can upload our dataset from upload button here. So after uploading the dataset, let's get started by importing Pandas, which will help us to manipulate our data. Next thing we are going to do here is let's write this line of code. Here, read CSVs from Pandas and helping us to read our dataset into variable name weather. And seattleweather.csv is a dataset that we have just downloaded from Kaggle and upload here. After running this, let's actually run this. We have also specified the index column as well as a date. We'll see later how specifying date as an index column is helping us. Now let's run a new cell called weather. Let's run this. And as you can see, there are like precipitation column, date column that we have seen earlier from our dataset, and maximum temperature, minimum temperature, and other wind and weather column details as well. So here is an example of how we can use index. If you want to see data for only first of 2012, we can do this. Here Locke is helping us to do that. Or if you want to look at data for specific range, let's say from like January of 2012, we can also do that. Setting our index as a dates makes it really easy to get slice of our data for specific date ranges. Now we have read our data and explored it a little bit. I think we are ready to go into the next step, which is cleaning our data to get it ready for machine learning. And most machine learning algorithms don't deal well with missing values. So first thing we are going to do is to see if there are any missing values and fixing them. So now let's find which columns have missing values. We can do that using apply method on weather data frame, and we'll pass in pandas is null function here, as you can see. And we have dot sum here, which will give us total number of null values in each column. So let's run this and see our data. Oh, this is interesting that we don't have any missing values. This seems to be a really perfect dataset, which doesn't happen all the time in the real world. And actually, when we download the dataset, usability was 10. Maybe that's why we don't have any missing values in this dataset. So let's go ahead. Now if you have a look back to our dataset, we have 5 columns: precipitation, maximum temperature, minimum temperature, wind, and weather. For this project, let's only use first 3 columns, and as well as our date as well, index column of course. And let's delete our wind and weather columns. And we can do that by using del. Now let's see our dataset again by running a new cell on weather. If we run this, we can see we have this dataset now. Next thing we are going to do is to take a look at our data types. In a machine learning algorithm, it's really important that values we are using to make predictions are numerical. And now let's see our data types. We can do that by using d types. Let's run this. As you can see, like our data types are numerical, which is great. We can also have a look at our index to make sure that it's also right data type. Our index at this point is just an object, as you can see from here, which means it's being treated as a string. But these are dates, so we can actually convert this to a date time index. So here we'll be using pandas to date time function to turn our index to date time index. And now let's have a look at this, and let's have a look at our index again. As you can see, like it's now been converted to date time index, and soon we'll see the power of date time index versus just a regular index. One of the cool things we can do with date time index is we can subset. So if you want to look at things by year, we can say weather.index.year, and it will just give us years. So we can do like this. So we can do the same for other parts of data as well. For example, if you want to see just months, let's write it months, and let's run this. We can see like it returns us months as well. It will subset us. This will be very useful when dealing with this kind of machine learning tasks, such as if you want to see average monthly temperature or average annual temperature. And now let's do some analysis just to see what's going on with our data. So here let's visualize maximum temperature and minimum temperature during the day. We can do that by using plot, as you can see here. Alright, this looks nice. And now let's also have a look at precipitation levels using plot as we just did before. Here, as we can see, everything looks good. This was just a little bit of exploration into our data. So now I think we are ready to train our machine learning model. Great, we've come a long way. Now first thing we'll be doing is to figure out what we'll be predicting. In this case, we are going to predict tomorrow's maximum temperature using historical data. So let's create a target for that. We are doing that using shift method. Shift -1 will pull every row back one position. What this here will do is create a column with tomorrow's temperature. So let's have a look actually in this. Let's run weather. We can see that there's a target column here. It's a maximum temperature uh, for tomorrow. For example, if you look at January 1st here, target is tomorrow's maximum temperature. All right, so we set up a target. Now here we can see that there's a missing value here in the last row because there is no tomorrow's data to use here. So let's get rid of that row. To get rid of that row, we can use iLock. Let's create it here and let's run weather one more time. Oops, I got an error. Yeah, here it is. So it's nice. Cool. Now let's import our machine learning model from Scikit-learn. We are going to use ridge regression for today, which is a type of a regression model that minimizes overfitting. So let's add it. We are setting the alpha here, which is a parameter that controls how much the coefficients of a regression model is penalized. And the greater the penalties, the more overfitting is prevented. So don't worry too much about this parameter right now. We'll just pass in alpha equals 0.1. Here we imported ridge regression, as you can see. So let's run this. After running this, it should have imported our model and initialized it to variable called rec. Next thing we are going to do is to create a list called predictors. So we are really explicit about what variables we are using to predict the target. Today we'll be using precipitation, maximum temperature for a given day, and minimum temperature for that day. So let's run this as well. And now after running that, we'll split our data into training set and test set. So we are doing it here by saying to June 30, 2015, this will be training set, and after that date will be our test set. This kind of split is really important when you are using time series data. What we shouldn't be doing is to use the data from future to predict the past. So we should always make sure we are using previous data to predict future data, not the other way around. So let's run this. So after splitting the data into training and test set, let's go ahead and fit this model to our data and then make some predictions. We can do this using fit method here on our regression model, and we'll fit to our training dataset with our predictors, and we'll try to predict our target. So let's run this cell. So our model has been fit, and now we can generate some predictions, and we'll generate predictions on our test dataset using predictor columns. After running this, we have our predictions. All right, once we have our predictions, we can see how well our model did. We are using mean absolute error to do that here. If you are not familiar with this term, mean absolute error, don't worry. You can think of it just as a difference between actual value and predicted temperature value. So here target is our actual value, and we have here predictions. So let's run this and let's see what our mean absolute error was. Okay, so here as you can see, this means on average we were 2.1 degrees of an actual temperature. Not bad, but of course there's a lot of room that we can improve our accuracy. Now we have generated our predictions and seen how well it did. So let's also combine actual temperature and predicted temperature values. It's so useful to do this in machine learning applications because you can see actual and predicted values side by side. It helps to see where there's a big difference, if any. Here we are using concat method to do that from Pandas. And also we have to convert our predictions to Pandas series here, as you can see. Uh, Otherwise, it's a NumPy array. And also in the last line of code here, as you can see, we have renamed our columns so it becomes easier for us to see. So let's run this. Let's also come to the new cell and run combined. Nice. We can see actual and predicted values side by side. We can also plot it here and we can have a visual look at our actual and predicted values. Here, as you can see, like there are some values here that's actually predicted way lower than the actual value. And in the other cases, where in this part, like it's predicted way higher than its actual value. Before wrapping up this project tutorial, let's have a look at coefficients of regression model to see how are the different variables are being used by the model. It looks like first variable, which is precipitation, doesn't affect that much to the maximum temperature of the coming day. And about this one, I think this was maximum temperature during the previous day. Of course, like this affects highly to the maximum temperature for tomorrow. And this is the minimum temperature, how it affects to our predictions. Hello everyone, so today we'll be building automate machine learning web app like this using Streamlit, Pandas and PyCaret. So we'll be able to upload our dataset, then we'll profile report it, and then modeling. Then we can even download our best model. Yes, so let's get started. So let's first, so let me clean this up first. Uh, let's first create a folder in our directory. Oops. So let's go here, IT, and let's name it AutoML project. And oops, AutoML. Uh, then before starting a project, we should always create a virtual environment so that uh, it doesn't mess up our system, our whole system. So let's create our Python environment. Let's create it VNV ML environment. Yeah, so let's go to that environment in Activate. Yeah, and so let's open it using VS Code. Yeah, and here let's start with, oops, let's start with an app file, app.py. Before getting started, I just want to note that we should firstly install our dependencies that's actually needed for our project. So let's start by installing pip install Streamlit because we'll be using it. Then Plotly, PyCaret, Y data profiling, Pandas, and last but not least, Streamlit, Pandas profiling. Profiling. I hope this is all right. Let's go. Great. So our dependencies has been installed successfully. So let's open our app file here. So let me open it one more time. Actually, let me first make it bigger so that it becomes easier to see. First, let's import our Streamlit so that it can render our data to the web. Let's first test it, and from the terminal, actually, from previous terminal, let's go to Streamlit, run app.py. Oh, I see. Here it is. So it's been rendered, as we can see. Now let's go to our next step, which is creating the sidebar. So let's actually delete this part. We just want to see if Streamlit is working all right. So let's create with st.sidebar, st.image, and then actually I had a picture like that I have looked up in the Google. Let's use that for our image. Yeah, fix it. So let's go here, st.title, which will be let's just put it like AutoML. Then now let's go back to our place, where we rendered our web app at Streamlit. Now let's reload it. Yeah, great. So there's a title as well as image that we have inserted there. So now let's create a navigation choice is equal to st.radio. Now select the task. Oops. Select the task. And what we'll be having is upload, as we have seen in the start of the video, and profiling. We'll be doing it using Y data profiling, and next one is modeling, and the last but not least is download, which will be able to download our best model that we have trained. Download. Yes, so here it is. And now let's go back to our web app. Now let's reload it. Yeah, cool. So as you can see, we can select upload, profiling, modeling, or download from the navigation. The next thing we'll be doing is we'll be just adding info here. st.info. This project application helps you build and explore your data. Yes, here it is. And now let's its state. Let's reload. Yeah, as you can see, like it's just an info box that actually tells like what is our project is going to do. Then we need some structure. So great, let's add some structure. Let's add some structure like if choice is upload. Oops, if choice is upload. Let's pass it for now. We'll come back to this, and let's actually copy this. If choice is upload, we have what else we have? We have profiling, and we have modeling, and last one is download. I think to download. Yeah, so we've done it. And what the next thing we'll be doing is to add functionality to upload a file here, this part, and we'll be using Titanic dataset. So like to do that, we had to upload, add functionality to here, and we can do that by actually let's get rid of this pass. First, let's add some title. Upload your dataset. Upload your dataset, and from here, file is the file uploader. Is the dot file uploader. Upload your dataset. Upload your dataset, and from here on, the file. Oops. Let's actually go back and see like how things are changed in our web app. Yeah, great. So with just a few lines, we will add this part using Streamlit. So as you can see, we can upload our files. Next thing, we'll need to read our file. For that, let's import Pandas. We have to import Pandas here. Import Pandas as PD. And the next thing is if file here, let's if file is data frame PD read CSV file. Actually, let's do it here. File index call none. Then est.data frame df, so that using st.data frame we can render it to our screen. Yes, so what we'll be doing next is we'll be taking this file and passing it to profiling, and we'll be doing it using Pandas as well. Great thing about Pandas profiling, actually, I'm sorry, like it's not Pandas profiling. It used to be Pandas profiling, but now like it has changed recently. We'll be using Y data profiling, which automatically profiles your data, so that we can use that inside of our Streamlit app. And then next, we save our data to our app folder here, so that we got it accessible through other tasks as well. And so here df to CSV, data CSV, data CSV, oops, .csv, and index will be none. And the next thing is, let's have if you upload our data file, actually it will be saved to our app folder. By doing that, you made it accessible through the app. Like, let's actually open the web app, where it is like here, I think. So if I load this, it will come up with this, and like if we upload our data here, it will automatically save that data set to our app folder and rewrite the name to dataset.csv, and we'll be able to use it alongside profiling, modeling, or downloads. So let's go ahead. And the next thing is we'll need to import Pandas profiling to get started with profiling. Let's import it. Oh, again, I said Pandas profiling. It's actually used to be Pandas profiling, but why data profiling? Why data profiling from Streamlit, Pandas profiling, import this profile report. Yes, yes. So here, let's actually give it some title. Let's see title. Let's put it as exploratory data analysis. It's everything. Sorry. The profile is equal to data profiling profile report df. Yes. And from here, explorative true. And yes, true. And from here, st profile or profile. Oops. Profile. Yes. Cool. So I think we're going well. Now let's go to our web app. Let's actually download some data sets. I think we'll be using Kaggle Titanic dataset. Let's use maybe this one. From here, let's download it. From here, AutoML. From here, let's download it here. Test it. CSV. Actually, let's rename it to just test it. So from here on, let's actually come back to our web app. Let's reload it, browse files, and from here, desktop. Where was OIT? Wait. Here it is, AutoML, and from here test CSV. select. Yeah, cool. So like as we have seen, like the data set has been rendered to our upload navigation part, and when it comes to profiling, name def is not defined. Oops, what kind of error it could be? Mm, I found out why we are having that error because like we actually didn't import OS, which is actually necessary for and necessary to access the data through other navigations. If os dot pass dot exist dataset history tab yes tab yes then yes tab. I'm just pressing the tab so it auto completes. Uh, I'm experimenting with GitHub Copilot. So yeah, and that's it. Let's go back to our web app. Where it is here. Now let's load, browse file. I think it was tested that we have used. Yes, here it is. We can see our data. Then if you go to the profiling, wow, cool! It's generating profile report. Let's see how it goes. Like it came up with a automate like profile report. So as you can see, like it comes up with variable analysis and name and sex, age, and arch and some things that everything in the data interactions. Like we can see the age, and we can see like correlations between different factors, different parameters, different features, and you can see this as well. Yeah, so this is it for profiling, and the next thing is we'll be working on modeling. We'll be actually using PyCaret for that, uh, so that it automatically selects the best model. So first things first, let's import PyCaret classification. Classification. Oh, oops. From PyCaret dot classification import setup compare models to compare our models then pull, then save model, then load model. Oops. Model. Yes, here it is. So now let's come to modeling part of our structure. Here what we need to do is we have to actually select the target before going on. Let's go to st.select box, select the target column, tab, and div columns. Okay, let's go to our app. If you come here, if you come to modeling, and if you come to as you can see, we can select the target. We'll be using survive because we want to know like what factors are related to like being survived in a situation of Titanic. Yeah, so now we can't it won't do anything because we can create the code here. So let's create it. Let's tab from here. Actually, let's first create a button so that like we can have control over when to run the model. So setup and df target is chosen target and setup df pull from here st.dataframe setup df from your best model, compare models, and then we can compare df, which is pull st.dataframe compare df, and let's actually render our best model here, best model. And finally, let's also save our model as best model. Let's actually save it to the different name than best model because we'll be having the best model in our folder. Let's actually do it as trained model. Yeah, so let's go back to our web app and let's try loading, browse files, test it. .csv, our data file. As you can see, everything is alright, so we can go to profiling. So it will generate the profile report as before. Yeah, we can see the profile report, and if you go to modeling, as you can see, like if you create the button, otherwise it would be like strange. And I select the survived, run modeling, so its target is survived or not survived, so it will be based on that. Let's see if it's going well. Yeah, so it's comparing different models here. Yeah, so this time, like, cool. Like, as you can see, like, we come up with some models, classification models. Actually, I'm not sure why this like regression model is here, as well as like the accuracy and recall is one, which is might be like overfitting our data. The thing is like if you can have a look here, like you can see a comparison of different models, how they have performed in our data. And also, like if you open our folder, we can see that the model has been saved in our folder as a pickle file. So the last but not least, the thing is like we should be like able to download that file through the web app. So let's go there and like write a code to download it. So like with open best trained model pickle, yeah, tab, trained model, load model, train oops, actually let me rewrite this part. st.download button, then download model, oops, download trained model, fread, file name trained model, pickle, and like actually we can get rid of this part. So trained model pickle. Yes, so I think this should be fine. Let's actually get rid of this as well. Here, file name, class model, trained model pickle. Yeah, let's go back to our web app. I think here it is. And if we come to download trained model, wow! So like as you can see, this is a model that's been actually saved during the training, and like after that, if we download it, it's like being downloaded as a new one. Yeah, so let's download it. Yeah, so that's all. Like if we come from like what we have done so far, firstly, like we created actually firstly we created virtual environments in our folder. Then we have installed required dependencies for our project. Then we have like put a structure such as sidebar, like, and putting up the navigation such as upload, profiling, modeling, and the last one is download. Then like giving the functionality to each of the parts in the navigation to the upload, to be able to upload and to make it accessible through our project. Yeah, we used the Kaggle Titanic dataset, as you can see here, and yeah, that's all. Like if you have any thoughts, feel free to leave them in the comment section below. Also, I would love to hear your suggestions for future videos. Thank you very much.